everybody. Today we're going to do lesson 9, and that is all about equivalent ratios. So the good news about this lesson is that if you are good with simplifying fractions and creating equivalent fractions, for example, when we need to add two fractions and they don't have the same denominator, and we needed to change the denominator so that we had the same denominator so we could add, we created equivalent fractions like that, you're going to be able to do equivalent ratios because it's the exact same thing. So again, this is something that's not technically new, it's just the way that we're looking at it that's new. So what we're going to do today is we're going to talk about how we find and how we determine if two ratios are equivalent, So let's look at the unlock the problem. To make brass, you can mix 2 parts of zinc to 3 parts of copper, which is a ratio of 2 to 3. If you have 12 bars of copper and use them all, how many bars of zinc do you need to make brass? So the thing about ratios is that in order to keep the ratios the same, the comparison between the two numbers has to stay the same. So even though we could have different amounts in a ratio, it's the same comparison. So the best way to think about this is with recipes. So very often we are using a recipe, and even if it's something as simple as, making pancakes from a box, I think of that example all the time because I know that in my house, with everybody in my family, 1 serving of pancakes is never enough. So we always have to double what's in the recipe. And what you're doing is you're taking ratios and you're keeping them the same when you do that. So it's the same idea. If you change the ratio, the recipe is not going to be the same. So if you don't keep the ratio of, let's say, flour and milk the same when you're baking something, it's going to taste terrible. You have to keep the ratio the same. So if you're going to put more flour in, you have to put the same amount of milk in too. So that's the idea when you're talking about equivalent ratios. So the best thing to think of to help you understand equivalent ratios is when you're making a recipe of some kind and you need to double it, or maybe you might need to cut it in half because you don't need so many servings of the food that you're making. Okay, and that helps you to understand what it is we're actually doing here. So that being said, we have this 2 to 3 ratio of zinc and copper, right? So it's zinc to copper. And that's a 2 to 3 ratio. Okay, we have to keep this ratio the same. What they're telling us is that we've got 12 bars of copper. So we know this part is 12 because it's copper, right? We need to know how many bars of zinc are we going to need so that we could keep this ratio the same, okay? Now, of course, you could draw pictures. For me, this is the best way to do it like this. So here's what I want to do. If you are good with working with fractions, you might want to set up this ratio as a fraction, okay, and do it like this. This is going to depend on what works for you visually, okay? When I work with ratios, like I told you yesterday, I like to use this symbol, but when it comes to writing equivalent ratios, you may prefer to look at it as a fraction. So here's why. Like I said, we have to keep the ratio the same. So the 2 to 3 has to stay the same. That means whatever I would multiply to get 12 here, I have to do the same to the 2. Okay, and this is why I might think to myself that using fractions might be better for some of you, because I need to see what do I multiply 3 by to get 12 here. Right, so whichever way you prefer, I'll do it both ways. I know in my head I must have multiplied the 3 by 4 to get 12, right? Or 3 here by 4 to get 12. And then in order to figure out how much zinc I need, I'm going to have to multiply the 2 by the same number so I can keep these equivalent. So 2 times 4 is going to be 8, or over here 8. And that's, in my opinion, the easiest way to do it. I do not prefer using models like this for ratios because it gets a little messy and sometimes confusing. Okay, and so how many zinc bars would we need? We would need 8, and that would be our answer. Okay, so the idea here is that the original ratio 2/3 and the one that we got 8/12 are equivalent. Okay, so it's the same exact thing as fractions. Okay, when you multiply or divide the numerator and the denominator by the same number, you get an equivalent fraction. Okay, it's the same for ratios. So as you can see here, I multiplied the 2 and the 3 both by 4 and got 8/12. And if I went backwards, I could see that I can divide 8 and 12 both by 4, and that would give me the 2/3 back again. So they're equivalent, and this is how we know that. You can write any number of equivalent ratios by just multiplying your original ratio by both numbers by the same exact number, or dividing it by the same exact number. So let's take a peek and see how we can determine if two ratios are equivalent. So for the try this, we want to see if 6/8 is equivalent to 18/24. So in order to do this, what we're going to do is they want us to write them as fractions, and I almost suggest that you all do it as fractions just because you're so used to dealing with them from this past year. But you can leave them as ratios if you want. I just don't want to add any more confusion. So the 6/8 ratio, we write as a fraction, right? 6/8, and then the 18/24. And then what we're going to do is we're going to reduce them fully. If when you reduce them fully, you get the same answer, then you know they're equivalent. So I know it's already solved over here, but I'm just going to show you. You think to yourself, what can I divide them both by? I know I can divide 6 and 8 both by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. So 3/4 is the reduced version or the simplified version of that ratio. Now 18 and 24, I can divide them both by 6. Okay, 18 divided by 6 is 3, and 24 divided by 6 is 4. So they both reduce to the same simplest form version of that ratio, which means that they are equivalent. So if you have to determine if two ratios are equivalent or not, you take them and simplify them as much as possible and see if you get the same answer. So let me show you some more examples. Okay. We want to determine if 3/5 and 12/20 are equivalent ratios. So first we'll write them as fractions. So the 3/5 ratio will be like this, and then the 12/20 ratio will be like this. Okay. Next, are they both in simplest form? The 3/5 is, but the 12/20 is not. So we're going to put that into simplest form. So 3/5 is already in simplest form. We'll leave that like that. But this 12/20 we have to take care of. So what can we divide both 12 and 20 by? Well, I know I can divide them both by 2, but there is something larger. You always want to go for the largest one, and that's going to be 4. I can divide 12 by 4, and I can also divide 20 by 4. So 12 divided by 4 is 3, and 20 divided by 4 is 5. So check it out. These are actually equivalent ratios because I can reduce them both down to the same simplest form. So yes, they are equivalent. All right, so I'm going to do 2 and 3 with you, and then you guys can try the on your own. So we want to decide if these are equivalent or not equivalent. So I have a 1/3 ratio. We're going to write it as a fraction, and then a 2/6 ratio. Okay, the 1/3 ratio is fully simplified. Remember, if you have a 1 in your numerator, it's already simplified. And now I'm going to see what I can divide both 2 and 6 by, which I know is 2, which gives me 1/3 or 1/3. So these are equivalent ratios. Okay. 3/7 and 12/21. So we'll write our 3/7 as a fraction, and that one's already reduced, so I'm going to box it off so I don't forget. And then 12/21, I can divide these both by 3. So let's see what I get here. 12 divided by 3 is 4, and 21 divided by 3 is 7. So as you can see, 3/7 and 4/7 are not the same. These are not equivalent. Make sure you don't jump the gun and just look at the original ratios and think, oh yeah, those are equivalent because I can see the 21 and 7, and you might get confused. So make sure you actually take the step to simplify them. Okay, so I would like you guys to pause and give these a shot, 4 through 12, and then unpause and check your answers. Okay, guys, as I was solving these for you, I noticed something that I forgot to tell you. Sometimes when you're looking to fill in the blank for a ratio, you won't be able to fill in the blank unless you simplify it first. So hopefully you figured that out on your own, but if you didn't, I'll explain. First, to fill in the blank here, 5 to 2 is equal to blank to 4. So what I did was, just to be consistent with the lesson, I wrote it as a fraction, right? 5 to 2. And then I'm looking for the numerator to the 4 here. So you just look and see, okay, how would I have gotten from 2 to 4? I multiplied by 2. So I have to multiply the 5 by 2, so you get 10 to 4. Number 5, however, when you set it up, what you'll see is you have a 3 to 6 ratio equal to 7 to something. You cannot just look here and say 3 times something gives me 7. So what you do is you simplify this ratio first. So you can divide them both by 3, and that gives you a ratio of 1 to 2 is equal to 7. So now you can figure it out. 1 times 7 gives me 7, so you multiply the 2 times 7 to get 14. Okay, and then here, this one worked out nice. 7 to 2 ratio is equal to what to 6? I know I'd multiply 2 by 3 to get 6, so I do 7 times 3 and get 21. 14 to 21, here's another one you have to simplify. 14 to 21 equals blank to 15. I don't know what 21 divided by 15 is. I can't figure out how to get from here to here. So instead, I simplify this. 14 and 21 can both be divided by 7. That gives me 2 to 3 is equal to this ratio. So now I can say 3 times 5 gives me 15. So I can take the 2 times 5, and that gives me 10. Okay. Here we have a 6 to 10 ratio is equal to blank to 30. This one I could simplify, but I can see what to do here. 10 times 3, so you don't have to simplify it. And then I need to do 6 times 3, so I get 18. And then finally, 8 to 9 equals 40 to what? I know 8 times 5 gives me 40, so 9 times 5 gives me 45. And then for these ones, you just simplify like we did above to see if they're equivalent or not. 3 to 5, and 21 to 35. I can divide these by 7 and get 3 to 5. So those are equivalent. Number 11, 4 to 3, and then 36 to 24. You can divide 36 and 24 both by 12. So that's a 3 to 2 ratio, so that's not equivalent. And then 27 to 72 and 9 to 24. 27 and 72 can both be divided by 9, which gives us a 3 to 8 ratio. And then 9 to 24 can both be divided by 3, gives us another 3 to 8 ratio. So those are equivalent. Okay, guys, so that's how you do equivalent ratios, nice and easy. My suggestion is to write them as fractions so that you don't confuse yourself with the new notation, just in terms of being used to using fractions already. Okay, so write as a fraction, fill in the blank. If you can't just fill in the blank, then you need to simplify your ratio first, and then you'll be able to fill in the blank. Okay, for these ones, you just reduce and see if they're the same. All right, have fun.